Okay, let's go ahead and start talking about factoring by grouping. So that's going to expand our skill set somewhat here. We're going to expand upon everything that we've been talking about so far, which was mainly greatest common factor and using that to factor. So now we're going to talk about factor by grouping, the concept of factor by grouping. Okay, so the best way to talk about this is to just jump right in with an example. So let's go ahead and factor 8xy plus 6x plus 12y plus 9. Okay, now it's called factor by grouping because what we do is we group these two terms together and we separately group these two terms together. And now what we have is one group of two terms here, one group of two terms here. So what we want to do is first just focus on these two terms here. So these two terms make up one algebraic expression, 8xy plus 6x. What we want to do is factor this algebraic expression here with the greatest common factor of these two terms. Okay, and that's something that we've been doing. Okay, we've been factoring algebraic expressions using the greatest common factor. So we're going to do that here, and then we're going to do it again here. So we really have to do what we've been doing, but just do it twice now. So find the greatest common factor of this mini algebraic expression here, 8xy plus 6x, use it to factor that, then do it again over here, use it to factor that, and then there are more steps to follow after that. So 8xy plus 6x, we're going to skip some of the details because we've been talking a lot about the details in the previous examples and videos and things like that. So what we're just going to do is say, okay, 8xy plus 6x. Now here we have 8 and an x and a y. Here's a 6 and an x and no y. So the greatest common factor is going to be, well, 8 and 6, the greatest common factor between those is just going to be 2. Here's x, y, and x. The greatest common factor is just x. Okay? And again, we're skipping the details in the interest of saving time because later on when we do more complicated things, we aren't going to want to focus on the details too much. And we did cover all these details in the previous videos and examples and things like that. So anyway, the greatest common factor is 2x. So then what that means is that 8xy plus 6x equals 2x times what's left over. What do we get when we factor out the greatest common factor? Well, 8xy divided by 2x. Remember, factoring is just dividing. 8xy divided by 2x, we have a 4y left over. Okay. And then 6x factor out or divide 2x, we have a 3 left over. Okay, so again, the greatest common factor of 8xy plus 6x of these two terms here is 2x, and we can use the techniques that we've talked about before to find that, and then we can use techniques that we talked about in the previous section to see what happens when we divide. Okay, so here what we have is, so far what we have up here, let's use a different color maybe. Let's go back to black for this. So what we have up here, 8xy plus 6x plus 12y plus 9. So far what we have is 2x times the quantity 4y plus 3. Okay, let's maybe make that a little more easy to read. 4y plus 3. Then we're going to have plus, okay, plus sign over here translates to a plus sign down here, plus what? What's going to be left over? Well, now we just do the same thing we did, but with 12y plus 9. So if we come back over here, let's use a different color to keep it separate. 12y plus 9. What's the GCF here? Well, the GCF here, here's 12, here's 9. The greatest common factor there is going to be 3. And then here's a y, here's no y. So actually that's it, just 3. 3 is the greatest common factor for this algebraic expression here. So then 12y plus 9, if we factor that with the greatest common factor, what do we get? 12y divided by 3 is 4y. 9 divided by 3 is 3. Because remember, factoring is just dividing. So then what we have here, go back to our black color here, 12y plus 9 we just found out is 3 times 4y times the quantity 4y plus 3. Okay, now again, this is factoring by grouping. So we grouped these two terms. We're factoring this entire algebraic expression here. We group these two terms together and separately group these two terms together. Now with our first group, we factored it using the greatest common factor, something that we've been talking about in the previous videos, so we know how to do that. And then separately, we factored this using the greatest common factor. something, again, that we know how to do because we've been talking about how to do it. And then what do we get? We get 2x times the quantity 4y plus 3 times the quantity 4y plus 3. Now notice in the parentheses here, in both terms here, so here's one term, here's the second term. In both of these terms here, we have the same thing in the parentheses, 4y plus 3, 4y plus 3. That's not a coincidence. That's actually what's supposed to happen when you factor by grouping. Okay, so when you factor by grouping, if you get different things in the parentheses here, something went wrong. Because when you factor by grouping, you have to have the same thing here. Why is that? Well, because the next step is to factor out this common factor. Okay, so it might feel and look kind of weird, but it's really a common technique that we do all the time. Okay, here's one term, 2x times the quantity 4y plus 3, that's one term. Here's the second term, 3 times the quantity 4y plus 3. Now notice they have a factor of 4y plus 3 in common. Okay, so they have a common factor that we can pull out. So when we pull out that common factor, what do we get? Well, what's left over is 2x times the 3. Okay, so 2x plus 3 multiplied by 4y plus 3. Okay, so notice 4y plus 3 appears here in this term. 4y plus 3 appears here in this term. So we have a common factor of 4y plus 3 that we just pulled out right here. And when we pull that out, when we factor it or when we divide it, what we have left is 2x plus 3. Okay? So here we just factored out the 4y plus 3. And remember, factoring is the same thing as dividing. So you can think of dividing this entire expression right here, divide that entire thing by 4y plus 3, and what you'll get left over, or the quotient, the result that you get is 2x plus 3. Okay? Now, if that looks or feels kind of weird, just think, we do that kind of thing all the time, right? Let's say, if instead of 4y plus 3, what if we had this? What if we had 2x times z plus 3 times z? How would you factor that? Well, here's a common factor of z. We would just pull it out. And we would have 2x plus 3, that quantity, times z, right? So that's something simpler, easier to work with. We've seen that kind of thing several times. Just a common factor of z to pull out. Well, it's the exact same idea here, but instead of z, we have a more complicated 4y plus 3. But that changes nothing, okay? The basic idea behind it, the basic principle, is still the same. We just have a common factor that we can pull out. 4y plus 3, 4y plus 3, common factor, pull it out, and what we have left is 2x plus 3, okay? So that's factoring by grouping. Basically just factor using greatest common factor twice, 2 separate times, and then after that, what you should end up with is a common factor that you can pull out like this. And again, 4y plus 3 over here, 4y plus 3 over here, not a coincidence. What you have in here and in here in the parentheses should be the same thing. If it's not the same thing, then something went wrong, and you have to go back and check what happened. But when you factor by grouping, these two things will be the same, and then the last step to do is factor out that common factor, and then here's our result here. So 8xy plus 6x plus 12y plus 9, when we factor that by grouping, we end up with this, quantity 2x plus 3 times the quantity 4y plus 3.